My name is Michael Hahn, and I'm one of the Vision Application Engineers here at R ViDi Company. And we are presenting today everything that we've learned in the last 5 months by applying Cognex's ViDi tools into machine vision applications. So the purpose of this webinar is to just share and pass on the knowledge that we've collected here on good applications for ViDi and why, and some of the details on the different tools and functions that Cognex brings with the ViDi tool set. So let's get started. Just as a kind of a place to start, our ViDi company, for some of you that may not know much about us, we're basically an automation solution provider that gets into hardware and solutions for automation in the manufacturing marketplace. So our whole goal is to bring high-end automation technologies to our customers through expert application, and basically to help our customers have a competitive advantage through automation and to reduce their risk in this automation by utilizing and leveraging our engineering services. Our core competencies are kind of broken down into 8 categories, and you can see to the far upper left here, machine vision. That's about 50% of what we do here. Then we get into the traceability, barcode, and 2D code, engineering services. We do a lot with robotics and vision-guided robotics. Get into machine control, material handling, flex feeding, and Industry 4.0. We take a look at our ViDi and the ViDi solution and what we kind of bring to our customers, you the customer. We have our ViDi engineering team. It comprises of 4 of our vision engineers, myself, Nick Parnello, Josh Hanford, and Jay Kors. Our goal is to basically provide customers the ability to collect images and then analyze those images. Those images can be collected here in the lab at our ViDi company or on a production line, and then taking those good and bad images and running it through the neural network of Cognex's ViDi solution. So we offer obviously the Cognex hardware and the ViDi software to prove that Cognex's ViDi solution is a good solution for different projects. We talk about ViDi. The first place we like to start is the difference between rules-based vision, which we're all familiar with, and the standard way of doing vision, and then the artificial intelligence or the ViDi way of doing vision. They're kind of just 3 different bullet points for each one. In rules-based, everything has to be defined, images that represent good and bad, and then really just a lot of time in just adjusting thresholds and histograms and basically getting it to where you've got an acceptable yield, at the same time rejecting all the bad ones that you want. With ViDi, it's a little bit different. You got to think of ViDi as your best operator on their best day, every day. So what we really need is just a good set of good images to run through the neural network, and then we load bad images just to confirm that we can reject it. So with ViDi, think about it this way, that Cognex has really got 3 new tools. So on top of their PatMax and PatMax Redline and Blob tools and all their other great tool selection that they have, we have 3 new ones. ViDi Check for assembly verification, ViDi Read to read optical character recognition or verification of very tough codes, and then ViDi Detect. That's basically looking for any kind of scratches, contamination, any kind of defects within an image. So we've got 3 new tools on top of all the other tools that Cognex offers. Let's start with the ViDi Check. The ViDi Check works really well in, and I like to take a look at where my cursor's at down here, where we've got a tray of a medical device or for surgical procedure. And like the syringe right here, that syringe could be upside down, could be backwards. We've got the tubing here. That could be in any orientation. ViDi does a really good job, just like a human would, to understand, hey, that's still the tube, even though it's not exactly in the same spot, and that's still a syringe. automotive assembly, really large fields of view where there could be a lot of different types of reflection, different colors, and it basically does a really good job to make sure, hey, all the parts are there where they should be. Let's take a look at ViDi Detect, and this is kind of looking for those really subtle small scratches or change in contrast and color and stuff like that. Here we've got a scratch in a plastic material. We've got a change in a knit or weave that's been put through, and we've got a scratch up here and then a defect here. Of all the applications we've looked at this one the most and been really pleasantly surprised at just how well this works, and then of course how quickly it is and so much faster to deploy a solution with ViDi Detect instead of the standard rules-based. The third one is the ViDi Read, and the best way to describe how awesome this tool is if you can read the characters with your own eyes, ViDi can read it. And that's of all the testing we've done in the last 5 months and all the applications, that still stands true. If you can read it, so can ViDi. Okay, so as I mentioned, you have these 3 new tools: ViDi Check, ViDi Defect, and ViDi Read. And they all are just in an addition, as you can see where my cursor's at, to all the other tools. The nice thing about where Cognex is going on this is that they've given it, or these tools, into our spreadsheet. So if you know spreadsheet and just can easily just add different tools, you can just now simply add the 3 ViDi tools. So it makes it real easy from a programming standpoint to utilize the power of ViDi. Okay, so the last 5 months and all the ViDi testing that we've done and taken a look at over 44 different applications. Some of these applications are from the past that we just couldn't solve before. Some of them we've done here just recently in our lab or on a production line. Out of the 44 different applications we looked at, we were able to solve 38 of those with ViDi. And that's obviously a big finding. Another finding on this too is that most of the applications, when we applied ViDi to solve them, took 80% to 60 to 80% less time in programming. So it's not that we can just do the very difficult applications, but deployment is so much faster. Here's just a list of all the good applications. So you see some of the, if you've been in Vision long enough, you see some of the applications we used to not entertain very well. Look at it, detecting cracks and scratches, solder quality. We got weld quality, plastic weld, cracks, difficult to read, glass, looking at quality within glass. It's always been a tough one, seal integrity. So we've got a lot of new applications we can solve now with ViDi. What I'm going to do now is I'm going to take probably the rest of the time and just go over some images and videos to kind of document some of the success that we've had. Here's the first one. We're looking at the ViDi OCR or ViDi Read tool. And there was actually 2 character sets that we were reading. We'll call it mold ID, that's the V28, and then core ID, that's and it's really difficult to see, but it's actually a 1, a 9, and a 4. The customer asked us to deploy this, I think it was a year or 2 ago, with their standard rules-based, and the best we could do, just because of the variability, is on the mold ID, we did 85%. That's on the V28. That's the best we could do read rate-wise. On this one here, it was much worse, 35%. What we did is we took those image sets and we ran it through the neural network of the ViDi Read tool, and in less than 2 hours, we got both of these to read 100%. Now that, first of all, is kind of just awesome and great news. The other thing was that the rules-based program that we put together took us over 100 hours. I think we had 3 different engineers working on it, so it just took a long time. It took us less than 2 hours with the ViDi Read tool. Here's another application where we're looking at the bottom of a container, and we're again tracking a mold ID number to the quality of all the other measurements that were taken on the container. And you can just see where my cursor's at in the top kind of smaller image that there's just hardly any contrast. Now, again, the rule is on ViDi read, if you can read it, so can ViDi. And you can kind of see, okay, yeah, it's upside down, it's a 0 and a 6. Or this one down here is a 0 and a 1. You look at that long enough, you can read those two characters, and ViDi can do the same thing. I'm going to play a video here that just kind of shows the library and how easy ViDi read is to use.
My name is Michael Hahn, and I'm one of the vision application engineers here at our ViDi company to show you another application solved utilizing the ViDi tool here at the ViDi Labs at our ViDi company. Here we've got an application where we're looking at inkjet printed characters. It's a pretty common application for our customers who want to take a look at having the ability to read these characters on several different packages. And of course, when that happens, the background changes. You can see that the height of the characters change, the width of the characters change, the overall length of the character string changes, but it's all still the same thing. It's all 17 characters that has this numbers and time-based information that's on there. So what we're going to do with the ViDi side here is run all of these through our library and create a solution so that we can read all these characters regardless of their size, width, shape, height, and other information. So with that being said, if I pull up my ViDi tool here and open up my editor, or I can just easily just jump over to here, you can see right now I've got my 6s showing up, and that's just one of the characters. Over here in the library that I've created, because of the ViDi read tool so easy, it comes with a built-in library. This built-in library has tens of thousands of characters that Cognex has put together, and so it was easy to train a number of these characters right out of the box. So if I just double-click on labeled, I have 1,017 zeros that I've trained as all the zeros that I might see. And you can just see of all the variability of all the zeros from one inkjet print to the next. Well, that's the kind of power that we have with ViDi. That's what we've done with all of these characters, is built up this library quickly and easily, and then applied the ViDi Blue tool to come up with the results that then are shared in the spreadsheet. So this application, it took about an hour to run through all the images and to train the tools and make sure and double check that everything was complete. And then because ViDi runs right onto the spreadsheet here, I still have access to all my other spreadsheet tools if I wanted to do anything else with this particular application.
Here's another application, just some images where we've got, we're going to apply a tracking tool to make sure that we have the right label. So we're utilizing PatMax, and that it's placed correctly. And then we're utilizing the ViDi read tool to read the inkjet characters down here at the bottom of the container. But the reason why we're highlighting this application is that we see the actual label ID number. And the cool thing about this is that that label ID number right here, the 415, where my cursor is at, that has a pixel, or the pixel size of 8 pixels wide by 12 pixels high. Most of the OCR applications with rules-based will not be able to read that. There isn't enough information there. ViDi, right out of the box, could read it. That means I didn't even have to teach a library or anything. The characters were automatically there on actually both sets. So once I drew the box over there, it actually knew, yeah, that's a 4, that's a 1, that's a 5. I didn't have to teach it anything. So the fact that I solved this one application just with one camera, and that deployment was so quickly and so fast. Here's a ViDi Defect tool now. This is a different one where we're looking at, cosmetic defects and changes. And this is a plastic weld. We've got the end of a weld here that we're looking at. And it's supposed to look like the one to the far left. The one in the middle has got a bad weld. So these gray, dark, different things could happen anywhere along this part. And then the one on the right shows the heat maps where the ViDi Detect tool has discovered it. Here's an application where we're looking at labels on a liquor bottle. What we've got here is we're looking at, all we had to do was collect 50 good images, and we loaded it through the neural network. And then we took and created a bunch of bad defects. And what happens here is you've got, your good images to the right in green here, and then your bad images to the left. And we've got a very good gap there. But you can see that it highlighted all the defects in the image to the top there. In fact, it was kind of cool. It found everything that we created and then something we didn't create. There was this really small little dot here, and as you can see in the upper image, it actually highlighted that. With rules-based, it would have just taken hours upon hours to put down all the different thresholds and all the different tools and all the different regions. Here, it took us less than 1 hour. Here's another application with the ViDi Defect tool. This is a plastic container. In the plastic blow molding industry, there are things called die lines where there might be a thin wall or a thin line, but there can also be just contamination and anything that can be, make the container not hold its liquid. So we're really familiar with this industry. We've got a lot of different solutions in there, rules-based. This application can be difficult because this die line can be anywhere, and that's where my cursor's at. With ViDi, it makes it real easy. All we did is just train a bunch of good containers, and then that was it. It found all the die line, and then it just found all the tiny little contamination defects. So that worked out really well. Here's another application. This is a video I'm going to show you, and it's going to show just how small of a defect ViDi can find.
My name is Michael Hahn, and I'm one of the application engineers here at our ViDi company with another solution from the ViDi labs here at our ViDi company. We're asked to look at a speaker cover. So what you have is an image before you, and in standard rule-based vision kind of applications, this application could be solved. It would just take a lot of tools and a lot of time, and maybe we might be able to catch some maybe more gross defects. But with ViDi, all we really need to do is collect a number of good images, and then learn on those good images, and then prove that it can catch the defect. And that all happened within 20 minutes of programming the solution. So that's what I'm going to show you here. What we have here is our database of good images. I'm going to move my screen over and take a look at the green images here and their score, and then the red images, which are the bad ones, and their score. So just at a first glance, I'm going to just click on the 51 bad images here. And at first, when you look at the screen, it's like, well, I wonder where the defect is at. But if I zoom in on this, you can see that the tool has highlighted this tiny little sliver in one of the holes. So here at the ViDi Labs, what we want to do is just kind of prove that is the defect and it is catching the right thing. Move to the next image. There it is. Go to the next image. I got to pan out a little bit to see where it's at. It's over here. So if I scroll back in, there you see right here where my cursor's at. I go to the next image. Here it is again. We only had one sample, so we just moved the sample around with the one defect, which we thought was the most difficult defect, and that was this little guy right here. Again, you can see the defect down here. So just as a first pass, and just running the good images and bad images through the ViDi Detect tool, I would say this is a great application for ViDi, and that is what we have here today. My name is Mike.
So that was an application showing some of the smallest defects. Here's another video that we're showing where ViDi actually found a defect that we weren't even aware of.
Hi, my name is Michael Hahn, and I'm one of the vision application engineers here at KMV. KMV provides turnkey automated inspection equipment for the blow molding industry, along with food and bev packaging, household chemicals, and home health care products. For more on KMV, you can go to kmvvision.com to get a look at the suite of solutions that would provide those customers in those marketplaces. Here we're looking at an application where we've got a container, and we're looking at the bumper area. So this is just looking, opening camera, looking at the opening of a container, and we're focusing on this bumper area where you can kind of see my cursors at. And so we've put down some tracking tools, and we're able to find the container wherever it is, as it moves underneath the camera, on the production line. So what we're going to show is the ViDi AI neural network algorithm that can find very slight changes to identify very difficult to inspect parts like we have here today. So I'm going to open up the ViDi editor, and that's what we have right here. In the ViDi editor, I'm allowed to load up a bunch of good images, run those good images through the Defect detect algorithm or ViDi neural network, and then basically gives me the results. Took a total of 15 minutes, and this is what I have. I have 129 good images and 60 bad images, and what I'm really looking for is a good gap, green being good and bad being bad. So all my good images are over here in green, and all my bad images are in red. There's no crossover, so that says I've got a very good ViDi application. We take a look at my good images, and here are all my good ones. It's basically with the variability of parts moving back and forth, rotating. That we're all good there. I go to my bad. I click on bad, and it'll highlight in the what we call heat map graphic overlay. That's kind of these kind of red spots that you see here. And if I turn that off, we can see, we've got the, there's a gouge here in the bumper. If I zoom out a little bit here, you can see the same thing on the top here. What's interesting, when we were looking at this application, we ran through the ViDi neural network, as we were taking a look at all of the defects, we noticed that there is a change here in this side right here. At first, we weren't sure what was the ViDi algorithm locating. We took a closer look, and we actually found out that right here in this bumper area is a very thin wall, and it's so thin that you can actually kind of almost feel it with your finger, and it actually bows up and is almost, I don't want to say see-through, but changes. So it's not flat like it should be, or sturdy with enough plastic material, but it's a thin wall and kind of bows out or up. And so ViDi actually caught that. So that's a nice thing about the ViDi algorithm. It kind of gives us kind of a real powerful tool to solve difficult applications with a lot of variability from one good product to the next. Anyways, that took about 15 minutes to program. We just tied that back to our overall job file here, and then we're able to solve the application with the samples that we have with one camera looking at from the top. Again, for any other
Moving on, here's another application where we've got, and we found a lot of success in applying ViDi to just the quality of labels, to make sure that the right label is on the right container, but that it's also in the right position, but that it doesn't have, and as you can see in the very top image here where my cursor's at, any kind of wrinkles or blisters or tears or scratches that can be anywhere in the label. So to program that with rules-based vision is difficult. It takes a lot of time, and you can really only find gross defects. But with ViDi, all you have to do is load, and all we did about 40 or 50 good images, ran it through the neural network of the ViDi defect tool, and we were able to catch even the slightest change in contrast by these two blisters here, and then scratches and mislabeled product. And it was anywhere within the region that I've got over here on the left that we could find any changes. So that really solved an application that never could be really solved before, but then it did it so quickly. Here's another application where we think there might be a lot of opportunity, and that is seal integrity, where you've got a package in food and beverage, or just really any kind of seal integrity. Maybe it's a plastic weld, or just kind of a... But anyway, what we have here is this area here with the stripes I've masked out, and then I masked out the very outer edge, and I'm just focused on the ViDi Detect tool around this edge right here. And so I'm just looking for any change. That could be from material that you see here in these little heat maps, or it might be a bad weld, or there might be a hole in there, or there might be other types of material or wrinkles or anything like that. And just rules-based, it's so hard to do. But with the ViDi Detect tool, it seems to be very robust, and the deployment is very quickly. So just as a summary, those are just a few of the videos and pictures of the 44 different applications we looked at. What we're bringing to you, the customer, is our team, our ViDi, and the 4 engineers, the Cognex software and the Cognex hardware solutions, and then also Greg Dahlstream and Associates, or GD&A, from a turnkey full integration solution. So that's the team that you, the customer, has to take a look at if ViDi can solve some of your most difficult vision applications. Just to review again, we've got 3 different types of new tools, right? You've got ViDi Detect, ViDi Read, and then ViDi Check. And then, of course, you have at your fingertips here all the equipment and hardware that our ViDi company has in our Vision Lab, and just the expertise that we've really been accumulating since we've been doing machine vision solutions since 1997. So after you get through this and you have further questions, or maybe you've got some applications you'd like us to take a look at, I think probably the best thing is just send me a quick email, mhan@rrfluty.com, and I can get some of our team on your application or answer any questions that you have. So I hope you enjoyed this webinar. Thank you.